Hello everyone. Today we're going to go over how to write or reduce a fraction into its simplest form. Let's begin with a couple of examples. Write the following fraction in simplest form, 30 over 120. The first step I'm going to take is to separate the numerator, or the top of the fraction, from the denominator, or the bottom of the fraction. Next, I am going to find the greatest common factor of the two numbers. If you are not familiar with greatest common factor, it is the largest integer that can divide both numbers evenly with no remainders. To find the greatest common factor, or GCF, I am going to use a method called prime factorization, and in this case, I will be using factor trees to do that. If you would like to learn a method other than prime factorization for finding the GCF, check out the Student Success Center's YouTube video titled Finding the GCF of Two Numbers for an Alternative Method. Let's start by finding the prime factorization for our numerator of 30. Well, I know that 30 will divide by 3, and 30 divided by 3 is 10. Now 3 cannot divide by anything other than 1 or 3, so it is a prime factor, and I can't divide it anymore. 10, however, will divide by 5, and it will leave me with 2. And again, 5 and 2 are both prime numbers, or prime factors, and they can't be divided anymore. So this factor tree is finished. Next, I am going to do the same thing and find all the prime factorizations for 120. Well, I know that 120 will divide by 10 and leave me with 12. And 10 will divide by 5 and leave me with 2. And 12 will divide by 6 and leave me with 2 again. Now 5, 2, and 2 are all prime factors, so there's nothing more for me to do on those branches, but 6 will divide by 3 and leave me with 2, and then 3 and 2 are prime factors, so I'm finished. So the next step in finding the GCF, or greatest common factor, is to circle all the prime factors these two numbers share in common on their trees. So there's a 3 in 30's tree and a 3 in 120's tree. And I'm going to write that 3 down here only once. There's a 5 in 30's tree and a 5 in 120's tree. And I'm going to write that below only once. And there's a 2 in 30's tree and a 2 in 120's tree. And I'm going to write that below only once. Now, although there is another 2 and another 2 in 120's tree, there's nothing that they would share it with in 30's tree, so I'm not going to write those, and I'm just going to leave them out. So my next step is to multiply all these numbers that I've written below together. So 3 times 5, that's 15, and 15 times 2, that's 30. So my greatest common factor of 30 and 120 is 30. So now that we have the greatest common factor, what should we do next? Well, we know that the greatest common factor will divide both the numerator and the denominator evenly, so let's divide. 30 divided by 30, or the numerator divided by the greatest common factor, is 1, and 120, the denominator, divided by the greatest common factor of 30, is 4. So my reduced fraction is 1 over 4, or 1/4. Now, if you're feeling like you're not quite comfortable with greatest common factor yet, and you just really need to reduce a fraction, there is another method that I recommend to a lot of students, and that is just simply to divide until you can't divide anymore. Now, the important thing about this method to remember is that whatever you divide the numerator by, you must divide the denominator by the same number, and vice versa. So what I'm going to do is simply pick a number that divides both the numerator and the denominator and divide them by that number. So I can see that both numbers end in a 0, so they're both going to divide by 10. So I'm going to divide 30 by 10, which is 3, and 120 by 10, which is 12. Now I'm going to guess that 3 will divide by 3, so let's see if 12 will as well. Well, 3 divided by 3 is 1, and 12 divided by 3 is 4. Now, 1 won't divide by anything other than 1, so if I divided 4 by 1, it would stay the same. So there's nothing more for me to divide here, and this is my fraction in simplest form. Let's try another example. Write the following fraction in simplest form, 21 over 22. First, let's separate the numerator and the denominator of the fraction. Now, let's begin with finding the prime factors for 21. Well, 21 will divide by 7 and leave me with 3. And 7 and 3 are both prime numbers or prime factors, so there's nothing else I can do with those numbers. So let's move on to 22. Well, I know 22 will divide by 2 and leave me with 11. And 2 and 11 are both prime numbers or prime factors, so there's nothing left for me to do with that tree. Now, what prime factors do these numbers share in common? Well, there's no 3 or 7 in 22's factor tree, and there's no 2 or 11 in 21's factor tree. So because they have no factors in their factor trees in common, the only number that would divide both of these numbers evenly is 1. And if we divide anything by 1, it stays the same, correct? So 21 over 22 in simplest form is 21 over 22. It was already in simplest form. If I had wanted to try the division method for this problem, I would have seen pretty quickly that there's nothing that would divide 21 and also divide 22, because 3 would divide 21, but not 22, 7 would divide 21, but not 22, and so that's pretty much it besides 1. So that's how I would have also realized that this fraction was already in its simplest form. Well, thanks for stopping by and learning something new today. If you would like to talk more in depth about the subject or would like some extra help with the concept, stop by the tutoring center at San Juan College for some one-on-one time with a math tutor. Don't forget to subscribe to the Student Success Center's YouTube channel for some more math help video and other general tutorial videos. See you next time!